Okay, in this part we talk about equations, inequalities, and factoring. It's just different stuff, I guess. Enough different that I wanted to do a separate thing. So number 23, all these are equations, and so we have to have like a little step-by-step for equations maybe. So step one, you want to simplify each side separately. So that's the distribute and combine like terms thing that we did at the end of part one. You want to use the equal sign as a sort of a divider. Number two, you want to add or subtract, doing the opposite, variables to one side, right? So all the x's go on one side or the other, which you choose. And then you add or subtract all the regular numbers to the other side. And then the last step is like once you add or subtract the variables to one side, and once you add or subtract numbers to the other side, you get to divide the number in front of x. And then you're done, right? So a lot of times you have these nice small equations that are not so bad. You don't have to go through all these steps, but this is just sort of a guide to help you. So simplify each side. There's nothing to do on either side. So moving on. Variables to one side, there's only one variable and he's on his own side, so there you go. But the numbers have to go to the other side, so I'm going to subtract 5. Now you might get to the point where it's pretty intuitive to subtract 5 right away for this problem, in which case, great, that's awesome. Don't forget, we still follow the same rules for negatives. 2 negatives mean we add, same sign, add, right? And there you go, that's your answer. Here, let me check out which ones are most like the ones you see on the test, and then I'll make sure to star those as well. All right. Okay. Number 24, we got negative 20 equal to 5 parentheses x minus 4. All right, so this one, yeah, I guess I'm trying to think. I'm looking at the final and looking at this worksheet and trying to find the one that's best like number 6 and number 8 and number 9. I know which one looks like number 7. All right, let's see. All right, so this one, after you do a little distributive property, looks, I guess, the most like one of the problems on there. But this one's actually kind of tricky, so I hesitate to point to it or put a star next to it. So the reason why it's tricky is because after you do distributive, then you go, okay, x is on one side, boom, numbers on the other. It means I'm going to have to add 20 to both sides. But look what happens on both sides. They cancel. So what do you write over here? 0. And then you divide, and you go, wait, when I divide by 5, is that 0 or is that undefined? I can't remember. Well, 0 divided by a number is 0. If it had been the other way around, it'd be undefined. But I won't give you a problem like that on the test. Don't worry. All right, number 25. We got 3 minus 2x equal to 9 minus 8x. This one, yeah, this one you should put a star next to. Yep. All right. We want x's on one side, numbers on the other. Now, the thing is, for both of these, remember, we're doing the opposite. Do the opposite. So if you see a plus, if you see a plus, do a minus. If you see a minus, do a plus, right? All right. So I want x's on one side, and I'm going to say plus 8x, because the reason why is it puts x's on the left side, like it cancels it on the right, and I like my x's on the left. See, over here I didn't do that because I didn't have to choose, but I could have. But you could also say plus 2x, and you'd be fine. It doesn't matter which one you do. Just make sure that you do different sign subtract, and then bring down anything that wasn't dealt with, like the 9 and the 3. And if you wanted to say subtract 3 from both sides to begin with, that's fine too. It is your choice. So these two steps, do the opposite with variables, do the opposite with numbers. As long as letters on one side and numbers on the other, it doesn't matter what order you do it. So I did letters to the left, so I need to get rid of this 3. Do the opposite here. Boom. So I get 6x equal to 6. And now the last step, divide, means that I'm going to get 1 as my answer. Okay? So definitely check that one out, knowing that you got to put letters on one side, numbers on the other. And it doesn't matter which way you do it. 26, we have 7y equal to 2, parentheses, y minus 5, and then minus 10. So this one, I think number 30s, I'm going to star that one. Let me look. Yeah, I'm going to star number 30. So this one is just a little bit of practice, you know. Distribute first, 2y minus 10, and then bring down this minus 10, don't forget. Even though you see minus 10, you go, oh, I wrote it. No, came from this. So you have 2 of them. And then we're going to combine like terms to get negative 20, because same sign add. This one's kind of tricky, yeah. All right, and then we got letters on one side, so I kind of want to do minus 2y to both sides. Do the opposite, yeah. That gives me 5y equal to negative 20. All right, letters on one side, numbers on the other. It's what I wanted. It's the name of the game. Divide by 5 is the last step, and I'll get y equal to negative 4. Yeah. Okay. Do one more on this sheet, number 27, on this piece of paper, I mean. 5 parentheses x minus 8 equal to negative 6 parentheses 2x plus 7. So I'm going to distribute first on both sides, and I'm going to get 5x minus 40 equal to negative 12x, and then that's negative 42, I believe. Okay, now this is very similar to this one. You know, x is on both sides, and we have to choose. I'm going to add 12x to both sides. That will make it nice and positive, and I'll get my x's over here on the left side, which is where I like them. Everything else needs to come straight down to where it is. You know, that'll help. So x's are on the left side. I need to add 40 to both sides to get rid of him. I'm left with 17x is equal to, what is that? Negative 2? Yep. So different signs subtract. Keep the larger numbers signed. That's the rule, right? So the 40s are gone. We just have 17x. And if I divide at the end, look what happens. It doesn't go evenly. Well, that's okay. I just have a fraction answer. Okay? No big deal. We can have fraction answers. Perfectly fine. Okay. That was number 27. And 28, I think this is the one I'm going to star. Yeah. So put a little star next to 28. So we have 2 plus x over 4 equal to 5x over 6. So there's only one equation with fractions in it on the final exam. So if you're not comfortable with these, you know, it's just one question, okay? But the thing you need to do is with fractions and equations, we're going to multiply the tops by the least common denominator of all of them, and then reduce or simplify, whichever you want to think of it. Okay, so there's a little thing from 2. So this is 2 over 1. First of all, any whole number needs to be put over 1 so you don't get confused. And then you go, what's the least common denominator of 1, 4, and 6? So the way I do it is I start with 6, the biggest number, and go, does 4 go into 6? No. Well, what's 6 times 2? 12. Does 4 go into 12? Yes. So my LCD is actually 12. This 1 goes into everything, so you know, didn't have to consult with him. So if your LCD is 12, I'm going to multiply all the tops by it and then reduce. So I'm going to say 12 times 2, I'm going to say 12 times x, and I'm going to say 12 times 5x. Now the thing with this is, do not change the denominators. So this is 24 over 1. This is 12x over 4. And this is 60x over 6. That's 12 times 5. These didn't change. Now, before when we did it, we did change them when we were adding and subtracting fractions, but this is a different thing. Here, you just do this. It's a new rule. It's a new situation. Find the least common denominator, multiply all the tops only by it. And what that does is it gives us fractions that reduce. This is 3x, and this is 10x. Wow. Squeaky chair, squeaky chair. Anyway, all right, so subtract 3x to both sides. That's what I would do. When x is on one side and numbers on the other, this number is all by himself. Now, I could subtract 10x over here and then subtract 24 over here, but that seems like more steps. So I'm left for 24 equal to, what is that, 7x? And then when we divide by 7, it doesn't go evenly. It doesn't even reduce. So 24 over 7 is the answer. Okay? If it doesn't reduce, then, don't do anything with it. 29 is another fraction one, and so, just some extra practice. I'm going to do 3 over 1 again because it's a whole number. So I change it to a fraction by putting it over 1. And then I say, what's the LCD? Well, I start with 4 and go, does 2 go into 4? Sure it does. Then the LCD is 4. Huh. And then I'm going to multiply all these tops by 4. Don't change the bottoms. And I'm going to get 20x over 4 minus 4 over 2, and that's equal to 12 over 1. Now I reduce, and I get 5x, I get 2, and I get 12. Okay. So no more fractions, and now we can say x is on one side and numbers on the other. I'm going to add 2. 5x equal to 14, and then I'm going to divide last up, and it doesn't go evenly again, so another fraction answer, which is okay. We accept fraction answers here, right? Okay, so a couple of fraction problems for you. I think 28 is probably the most like the one on the final, but both of them are very similar, so you can use both of them as little guides to help you. Number 30, you're going to put a star next to, because there's a problem like this on there. It's a bunch of simplify business that you need to do at the beginning. So 10x minus 3 parentheses x minus 2, all of that junk we need to distribute first. Bring down the 10x just like he is, and that becomes minus 3x, and that becomes positive 6. Negative times negative is a positive, right? On the right, there's nothing to do. And then it's got some like terms on the left, so I'm going to go ahead and subtract those. They're different signs. Larger number is positive, so I get positive 7x. That's equal to 12 plus 5x. Okay. Now I need x's on one side, so I'm going to subtract 5x. Now it's your choice. You could have subtracted 7x if you want, but, I like this better. Everything else comes straight down. I'm going to subtract 6 to both sides, so I get the numbers on the other side. Get 2x equal to 6. And then the last step, divide by 2, and I get x equal to 3. Okay. So that's all the equation business on this. Oops. So that's all the equation business on this sheet. Now let's look at inequalities. They're very similar in how we solve them. So if we have something like 2x minus 19 less than or equal to 1, that is like a nice little simple inequality for you to start with. And with this one, I would treat it like it's an equation first. So I see x is on one side, I need to get numbers to the other. So I add 19 to both sides. Boom, to x less than or equal to 20. And then I divide by 2, and I get x less than or equal to 10. And that's the answer that you will have as an answer choice on the final exam. So you don't have to convert to interval notation for that, but there is one question where you ask to convert to interval notation. So let me do that for you for each one of these problems. So we started, here's 10 somewhere on the right side of the number line, and this less than or equal to is pointed to the left, so that's the arrow. And since it's got a little line underneath it, we're going to use a bracket, right? Now what number's over here? It's negative infinity. So when we write the interval notation, we're just going to write these two numbers side by side, negative infinity with a comma in between, and then 10. Okay? And then instead of the line, we'll just put a comma, and then we put the bracket next to 10 and parentheses next to negative infinity, always. So this is the interval notation for x less than or equal to 10. It's negative infinity to 10. You only have one question where you have to do this. So, if you're not comfortable with it, it's okay. This one, you have 3x less than or equal to 12. If this was an equation, you just divide by 3, right? No big deal. X is less than negative 4. And that's the answer there. But if I'm going to change this to interval notation, here's negative 4 somewhere on the left of my thing, and this is pointing to the left. But since there's no line underneath here, we're going to use a parentheses at negative 4. So again, negative infinity is over here. We write negative infinity, comma, negative 4. Those are the two numbers. We're going to use a parentheses and a parentheses. Okay. 33. This one, put a star next to because it's on there. Not exactly like it, but pretty close. So negative 3x greater than or equal to negative 12. Now notice something. Back here, when I divided by 3, nothing happened to this inequality symbol. Nothing. It was less than, stayed less than, it's pointed to the left, right? No big deal. Even though this guy's negative, I don't care. But this guy has a negative in front of him. So because he's negative 3, when I divide by negative 3, this is going to change. So it was greater than, now it's less than. And two negatives make a positive, and that just leaves us with x, okay? So there's the thing. When you divide by a number in front of x that's negative, you're going to flip this sign. But this guy was positive in front of x, so nothing happened. Same thing here. I added 19, or if I subtracted, nothing will happen to this guy. Only when the number in front of x is negative and you're dividing. That's the only time this happens. Okay. And again, if we draw an arrow, you don't have to draw an arrow if you get really good at going straight from this to this, but I like to draw the arrow. I like to draw this going left with parentheses and then going, oh, negative infinity is over here. So this is negative infinity to 4 with parentheses. All right, 34. We have put a little star next to him because he's kind of similar to 1 on the final. And it's just a little bit of simplifying nonsense at the beginning. Just like with an equation, you would distribute and then distribute. And if you don't understand what's going on with this distribute, change this to negative 1. That'll help you maybe understand that better. So 5 times x is 5x. 5 times 2 is 10. That stays the same. Negative 1 times x is negative 1x. And the negative 1 times 2 is negative 2, right? And now we want x's on one side, so we're going to add 1x to both sides. I will. I want my x on the left, by the way, no matter what, with inequalities. Everything else straight, exactly the same thing. Now, minus 10 on both sides. And we get 6x less than or equal to negative 12. Again, same signs, add. Keep the large number sign, keep the sign. And then we're going to divide by 6. And when we divide by 6, nothing happens to him because the number in front is positive. I kind of wish one of them had been greater than so you could see an arrow pointing to the right, but ew. Here's negative 2. There's an arrow pointing to the left once again, but with a bracket. So you're going to have negative infinity to negative 2 with a bracket like this. And infinities always get a parentheses. Okay? Okay, so that's the inequality business, and then we skip 35 through 56. So 35 through 56, skip. Okay, none of that stuff is on the final. It's on a bigger final if it was in class, but I'm trying to make it a little nicer. So we're going to jump right over to 57, the factoring business. Now there are I believe 4 questions on factoring. Let me find it real quick. 1, 2, 3, 4, 5. 5 questions on factoring. Okay. There's GCF, so anyway, I'm good, it's fine. So the first 57, 58 are factor by grouping. Now there's no factor by grouping on the exam. Isn't that nice? But I'm going to show you one just so you know how to do it. So we have 21x squared minus 24xy plus 28xy. If you want to skip ahead, you can. Minus 32y squared. All right, so with factor by grouping, you want to split it up in the middle. And then you want to do GCF on both sides. So this would help to understand GCF a little better because there's a GCF problem on the final that's not on the worksheet. So this is a way of looking at GCF by looking at this. Sorry. So 21 and 24, you're going to find that they both have 3 in common. And then they both have an x in common. But they don't both have a y, so it's just 3x is what I'm going to divide both of these by to get what's in parentheses. 21 divided by 3 is 7. X squared divided by x is x. 24 divided by 3 is 8. The x's cancel, and you're left with y. Now this is stuff that you learned online, as I was doing problems for you in quiz 5 and quiz 6. Wait, quiz 3, quiz... No. All right, so look, the factor quizzes are 4 and 5, I believe. Is it 4 and 5? Maybe 3, 4, and 5. So definitely go back and look at those quizzes to figure out, how to best do GCF and how to do factoring trinomials, which I think is 4. This is GCF and grouping. This is trinomials, and this is the special ones, the difference of squares and such. All right, over here we have 4 is a number that goes into both of them, and they both have a y. So I'm going to divide by 4y both to get what's in parentheses, and I'm left with 7x, the y's cancel, and then 8y. Okay. Now, the way you put this together is the common parentheses that they have gets written once. And then what's left over, 3x plus 4y, gets put in their own parentheses. There you go. Okay, so that's just a factor by grouping problem with 2 GCFs inside of it so that you get a little practice doing GCF. If you want more practice with GCF, definitely look at this quiz, quiz 3, and the video that goes with that, 6.1. Talks about GCF and grouping. I'm going to skip 58 because factor by grouping is not on the test. I'm trying to save you some time. 59 is a difference of squares, and I know that because I recognize those square numbers, 64 and 1. I see that minus sign, I'm like, okay. Now the difference of squares is you think of the plus minus thing. So I don't know if you need to write that somewhere. Difference of squares means the plus minus thing. What I mean is you break them down. This becomes 8b and 8b. And this is 1 and 1, right? You're taking the square root. You're saying what times itself give you that. And then you do plus minus, and that's it. That's all there is to that. Number 60 is a GCF problem. And I know because I've been doing this a long time. But you know because right away is only 2 terms, and these aren't squares. So the only thing left is GCF. But not only that, you're supposed to check GCF first every time. Just as a general rule, but you don't have to worry about that much on the final exam. I'll tell you if it's a GCF problem. So this is a GCF problem, and we're going to see that they both have a 4 in common, and they both have an x in common. So when I divide by 4x from both terms, I get 5x plus 2, and the x's cancel. Done. All right, 61. Here we get to the trinomials. Now this stuff is on the final. So I'm going to do a little star next to him. I'm going to do a little star next to 59 as well. There's one of those on there. And then there's this one, which is asking you to do the little x method. Negative 37 in the top, positive 36 in the bottom. And you say, what two numbers multiply to give me him, but add to give me him? And that's 1 and 36. And this is sometimes can be tricky because you don't think of this pair very often. Or, I don't know, some people have a problem remembering that pair. But yeah, you can always have 1 in the number to be your pair of numbers that work. And they add if they're both negative. So x minus 1 comes from the negative 1. X minus 36 comes from the negative 36. And this would be the answer, except that on the final exam, I say there's only one factor as an answer choice. And so you just need to look at the answer choices and find one of these, and that's the answer. I'm not going to put both of them. So don't worry about, which one do I pick? It's not going to happen like that. All right, 62, we have 10x squared minus 40x minus 120. Now here's a problem that has GCF first. You don't have to worry about this one. I didn't do that to you on the final. Let's see. Making sure. X. Yeah, they're all just regular x squared problems, trinomials. And so there wouldn't be a number in front of any of them. So you don't even have to know snowflake for the final exam. But I want to do this problem because it's GCF. They all have a 10 in common. And if I divide a 10 out of all of them, I'll be left with x squared minus 4x minus 12. And this guy is a problem that you'll have on the final exam, So let's go off and do a little x method again. Negative 4, negative 12, like so. Negative 4 on top, negative 12 on the bottom. Sorry, I forget to say this out loud. I don't know why. Then I say, what two numbers multiply to give me 12 and subtract to give me 4? So I think of what two numbers multiply to give me 12. 4 and 3? Yeah, but they subtract to give me 1. So I write 4 and 3, and then I cross through them. So I stop thinking about that. And then I go, what about 6 and 2? Yep, that's the answer. 6 and 2. Now, you have to have the larger number match the top number in its sign. So 6 needs to be negative. 2 needs to be positive. So this will give you x minus 6 and x plus 2. And if this were a factoring problem, I would bring down the 10 and put a big box around the whole thing. But on your test, you're just picking the answer choice that is one of these. So you'll see either x minus 6 or you'll see x plus 2, and that's your answer, okay? All right, number 63, I don't need to do because that's got a number in front. We don't need to do snowflake. And number 64 has a GCF, but then it'll have a number in front, and I don't need to do that either. All right, I feel like I should do one just so that you see it. But since this is preparing you for the final, I don't want to confuse you. So here we go. That's the end.